So today's lesson we're going to look at removing fractions, decimals, and parentheses, also known as brackets. I'm going to show you two different methods for three of the problems. So our first example says solve the equation, and we have 2x is equal to 3x plus 1/2. So I'm going to show you method 1 first. And remember, our goal is to find out what x is equal to. Okay, so I just want to know what x is equal to make this equation true. So I'm just going to rewrite this. 2 over 3x is equal to 3 over 4x plus 1/2. Now notice that this term and this term both have x's. So I'm going to bring them both to one side. So I want to bring them to the left-hand side in this case because I already have something on the right-hand side. So to get the 3/4 x to the other side, I'm just going to subtract by 3/4 x because 3/4 x minus 3/4 x, so something minus itself is equal to 0. And on this side, of course, whatever I do to one side, I must also do to the other side. So this looks like 2/3 x minus 3/4 x is equal to 1/2. Now I have both of my like terms on one side. Now we have fractions. So with fractions we have to find a common denominator. In this case the common denominator happens to be 12. So I have something over 12x minus something over 12x is equal to 1/2. How do I get 3 to 12? I multiply the top and the bottom by 4. And on this case, how do I get 4 to 12? I'd multiply the top and the bottom by 3. So I now have 8 over 12x minus 9 over 12x is equal to 1/2. Alright, I'm just running out of a little bit of room, so I'm going to go like this. And I have 8x over 12 minus 9x over 12, which is negative 1 over 12x is equal to 1/2. Sorry, half. And then again, I'm trying to get x all by its lonesome. Right now there's a negative 1/12 in front of it. Notice if I multiply both sides just by 12, then the 12 will cancel out. However, it would still be, there's that negative in front of there. So if I multiply both sides by negative 12, then the negative becomes a positive, and we get x is equal to, and over here I'm going to cancel 2 and 12. This becomes a 6 and 1. And so 1 multiplied by negative 6 is negative 6, and the bottom is just 1. We don't like to write 6 over 1, so our answer is x is equal to negative 6. So this was the first method, and I'm just going to move this over a little bit so I have enough room for the second method. I do want you to watch both methods because they have equal value. And method number 2. So I'm just going to start off by writing down the equation again. So I've got 2/3 x is equal to 3/4 x plus 1/2. Just tab over a bit so we have a little bit of room. And because I don't really like working with fractions, this is a method that will get rid of the fractions in the first step. So first I'm going to find the lowest common multiple between all of the denominators. So 3, 4, and 2. So the lowest common multiple of 3, 4, and 2 is 12. Now what I'm going to do is I'm going to multiply both sides by 12. Now you have to multiply everything on both sides, so it's really important. Put in some brackets. I'm going to multiply this side by 12 and this side by 12. And so if I rewrite this just so we can all see it, so it looks nice, we have 12 multiplied by 2/3 x is equal to 12 multiplied by 3 over 4x plus 1/2. Now, why this is nice is that these are just like over 1, and I'm going to multiply everything on both sides by 12. So everything on both sides by 12. The first side, there's only one term, so we can simply reduce this, but just so that we can see exactly what we're doing, and we don't make mistakes on the other side, I'm going to write it down like this. So it's 12 over 1, and remember we have to distribute just like in our polynomials unit. So we get 12 over 1 multiplied by 3/4 x plus 12 over 1 multiplied by 1/2. Okay, so it's really important that 12 multiplies everything inside of those brackets, each term. Now I'm going to simplify things. So 12 divided by 3, so we can rewrite that as 4. And then on my left-hand side, I end up with just 4 times 2x, which is 8x. And the bottom is 1 multiplied by 1. We don't need to write the 1 anymore. And then on the right-hand side here, we can cross-reduce here. And we end up with 9x. And we can cross-reduce here. I get a 6 out of that, plus 6. And then now I'm just doing a very simple solution. I'm just going to subtract 9x from both sides. So I get negative x is equal to 6. I don't want negative x. I want to know what x equals. So if I divide both sides by negative 1, or you could alternatively multiply both sides by negative 1, whichever way you want to think about it, I get x is equal to negative 6. Notice both ways I got my answer. This way I didn't need to use my fractions as much. It was just dependent on using this method of multiplying both sides by the lowest common multiple. And it is everything in the equation, every term gets multiplied by that. Now remember, if you are stuck on this at the end, you can always check. If I plug 12 back into my equation, I'll show you one here. So if I check this one, I've got x is equal to negative 6 as my solution, 2 over 3. Now, wherever I see an x, I'm going to substitute in that negative 6, because I'm choosing x to be negative 6. 3/4 multiplied by negative 6 plus a half. I'm going to cross-reduce here. 3 is a 1, this becomes a 2. On this side we've got, this becomes a 2, and this is going to become a 3. So I've got negative 4 is equal to 9, negative 9 over 2 plus 1/2, which becomes negative 4 is equal to negative 8 over 2, and this is equal to negative 4. So negative 4 equals negative 4, and we got the solution correct. So at the end of your test, you should check all of your solutions just to make sure that you got them correct. Alright, again, I'm going to show you two methods for this one. Alright, method number 1. Now, I'm going to write out the equation quickly. 2x plus 5 over 2 plus 2 over 3 is equal to x over 6. So the important part in this one is that we don't have cancelitis. So from the last unit we looked at this as well. These two things do not cancel. Okay? What this is actually telling us is that 2 is dividing every single term in that fraction. So we can write this as 2x divided by 2 plus 5 over 2 plus 2 over 3 is equal to x over 6. This is really important. The 2 is dividing every term in there. Just as if you had, for example, 2 plus 1 over 3. Okay? Now, right away, most of us would just say this is 3 over 3, which is equal to 1. But you can also look at this as 2/3 plus 1/3. And 2 plus, they have a common denominator, so 2 plus 1 is 3 over 3, which is equal to 1. Okay, so that's just with some numbers so you can see that. I am going to erase that so that we can have some room. Alright, now with that said, we can do the same, finish it the same way as we did method 1 from question 1. So I'm going to get all of my like terms on one side. And it's easy in this one to just subtract negative 2x over 2. Also, if you wanted to simplify this right now, this is a good time. This is equal to just x, because 2x divided by 2, 2 divided by 2 is x. So if you wanted to do that as well, that's fine. So I'm just subtracting x from both sides. So here I'm left with 5 over 2 plus 2/3 is equal to x over 6 minus x. Alright, so I'm going to have to find common denominators for both sides. Now the left-hand side, the common denominator is going to be 6. So to get this to 6, I'm going to multiply the top and the bottom by 3. And to get this to 6, I'm going to multiply the top and the bottom by 2. So we get 15 here, and over here we have 4. On my right-hand side, the common denominator is just going to be 6. So This one's nice and easy. And now I'm going to collect my like terms. So on this side, we're just adding these two because we have a common denominator of 6, and this becomes 19. On my other side, I've got a positive x minus a negative 6, which is why we're going to get negative 5x. Be really careful with that one. And then again, my goal is to get x equal to something. Okay, I want to know what makes this statement true. And so I need to get x by itself. So if I multiply this by 6 now, notice that this one will become a 1. I still have that negative 5, so notice that if I divide by negative 5, then here this becomes a 1. Now whatever I do to one side, I must also do to the other. So this is multiplied by 6 over negative 5, and I can simplify on this side as well, because 6 divided by 6 is 1, and so I'm left with 19 over negative 5 is equal to x. We never ever leave negatives in the bottom. You can write your answer as x is equal to negative 19 over 5, or you can make it equal with the negative just in front. These two would give you full marks. This one I would definitely take off half a point at least, because the terminology isn't correct. Now I want to show you another method, and just to make sure everyone's aware, those were the answers. Here we're going to look at method 2. And I personally like method 2 better, but you just have to be really careful so that you don't make mistakes. Now here we've got 2x plus 5 over 2 plus 2 over 3 is equal to x over 6. Now again, just like the method 2 in the other one, what we want to start off by doing is find the lowest common multiple between 2, 3, and 6. So again, this is just going to actually be 6, so it's nice and simple. I'm going to multiply both sides by 6. And now here you can see very simply this is going to become a 1, and so this is nice. This is just x over here. And now on this side you have to be really careful. Now we're distributing to each of these terms. I would say right away put in some brackets around the 2x plus 5 so you don't get things confused. So what we have is we've got 6 multiplied by 2x plus 5 over 2 plus 6 multiplied by 2 over 3. I'm going to write these over 1 so that I can do some cross reduction. And the nice thing is that 2 and 6 will cancel out and we'll get a 3 over here now. And over here we get 6 and 3, which becomes a 2. And so this just simplifies to 3 multiplied by 2x plus 5 plus 4 is equal to x. Now, and this was what was really important about those brackets, is that this, notice, the 3 multiplies everything inside of here. So we end up with 6x plus 15 plus 4 is equal to x. I need my like terms to become together, so I've got those two, and I get 19 is equal to, actually I'll do a step back. And I'm going to subtract 6x from both sides. So we get 19 is equal to negative 5x. Divide by negative 5 on both sides. And I get 19 over negative, we're going to rewrite this as negative 19 over 5 is equal to x. I got the same answer in both. Method 2, a lot less work. So with decimals, it's fairly similar to when you have fractions. We could just simply add and subtract the fractions if we wanted. Alternatively, we could multiply both sides by some sort of multiple of 10 so that we no longer have decimals and we have whole numbers, which would be nice. So I'll show you both methods. I like when the multiplication method, the second method, better, but both are correct. So method 1, we've got 0.08x plus 0.007 is equal to 0.05 minus, just mush this over a little bit. There we go. Minus 0.006x. Alright, so again, we're trying to find out what x equals. So I'm going to take my like terms, get them on one side, and then we can solve for x. So if I add 0.006x to both sides, Then over here we're going to get 0.086x, and I'm going to subtract 0.007 from both sides. On this side, I'm going to have to put a little 0 in there, and I'm going to have to carry the 1, so I get a 4, and I'm going to get 0.03. Alright, now I can divide both sides by 0.086. So I have x equals 0.043 over 0.086. Now we never leave fractions and decimals and fractions. So therefore, what we're going to have to do is we're going to have to multiply both sides by, in this case it's going to be 1,000, and we get 43 divided by 86, which is just equal to a half. So our conclusion is x is equal to 1 over 2. Now, my other method, much nicer. We get rid of the fractions right away, and I want you to notice that I did actually have to multiply by a multiple of 10, and in this case we're just going to do it much earlier, and I think it makes it a little bit easier for us. So I'll write out the question again. Now if I multiply both sides by, I want to look at the smallest decimal, so these are my two smallest decimals. To get them over the decimal place, I'm going to have to multiply both sides by 1,000. So here, I'm going to multiply this side by 1,000, and on this side as well, I'm going to multiply by 1,000. And remember, this is being distributed across everything inside the brackets, and therefore 0.08 multiplied by 1,000 becomes 80x. 0.007 multiplied by 1,000 becomes 7. 0.05 multiplied by 1,000 becomes 50. And 0.006 multiplied by 1,000 becomes minus 6x. And now I can just simply add 6x, add 6x. I'm going to subtract 7, and over here I get 86 is equal to 43. Oh, I forgot my x. Divide by 86, x equals 1/2. Alright, I was going to show you a fourth example, but I think we covered it enough in these questions that we don't have to go on any further. Clearly you can see that this method was quite a bit easier. It took us way less time. We didn't have to deal with decimals, which was nice. These methods up here, I like the ones where you get rid of the fractions right away by multiplying by the lowest common multiple. Again, but you have to be very careful. Things like these brackets are super important, and sometimes we forget those, so just make sure that you're totally on your game when you're doing these.